Hello everybody. This is about oscillating light clock. The title of the paper is Oscillating Light Clocks Review the Possibility of Time Conservation in Moving Frames. My name is Tao. In the current physics books on Einstein's relativity, it is mentioned that time dilation happens in moving frame. However, here we will show that time conservation is possible in moving frames. Here is the abstract. Oscillating light clock is invented and its behavior is investigated. Time conservation is found in the oscillating light clocks. This means that time would be neither dilated nor contracted in the oscillating frame if the angular velocity of the oscillating motion took some quantized values and the curved trajectory of the light rays. This means light bending seen by the mirrors in the oscillating light clocks are plotted. This video shows a stationary light clock. In the light clock, the photon bounces up and down between the two mirrors. And here, the green colored disk represents the photon. The blue light segment represents the light trajectory, also the trajectory of the photon. And the two black rectangles represent the two mirrors. Okay, here we can see that this kind of a pattern constructs a light clock, and we call it a stationary light clock. This video shows an oscillating light clock. The two mirrors conduct an oscillating motion in horizontal direction, and the photon bounces up and down between the two mirrors in vertical direction. Initially, the photon is at the position of the bottom mirror, and then the photon hits the top mirror. After the top mirror conducts a complete oscillating motion and goes back to its initial position. And then the photon hits the bottom mirror. After the bottom mirror conducts a complete oscillation motion and goes back to its initial position. Okay, here we can see that this kind of pattern constructs a light clock, and we call it oscillating light clock. Here we compare the stationary light clock and the oscillating light clock, and we can see the time conservation happens here. It means that the elapsing rates of time in the two frames are same. This slide shows one tick of a clock corresponds to two complete oscillations of the mirrors. One complete oscillation corresponds to the situation that the two mirrors start from the leftmost position and then reach the rightmost position, and then again reach the leftmost position. Video B here shows the curved light trajectory seen by the mirrors. This means the light bending in the oscillating frame. This slide shows the one tick of the clock corresponds to 4 complete oscillations of mirrors. And video B here shows the light bending in the oscillating frame. This slide shows one tick of the clock corresponds to 6 complete oscillations of the mirrors. And video B here shows the curved light trajectory seen by the mirrors. This slide is about the mathematical explanation of oscillating light clock. Equation 1 shows the velocity of the mirrors. Equation 2 shows the oscillating motion of the 2 mirrors. From equation 2, we have the equation 3, cosine omega dot t equals 1. And then we have the equation 4, omega dot t equals 2n pi, where n is a positive integer, such as 1, 2, 3, 4, and so on. And then finally, we have the equation 5, omega equals 2n pi over delta t. Delta t is the time interval for the photon to leave one mirror and then reach the other mirror in each step. And the step corresponds to half tick of the light clock. From equation 5, we see that if the angular velocity of the oscillating motion were equal to some quantized values, the phenomena of time conservation would happen in the oscillating frame. Here we want to address 2 points. The first one is the ergodicity of the behavior of time. The oscillating light clock here show that time in moving frames may go as quickly as it does in stationary frame. This means time conservation. Uniform moving light clock shows time dilation, and the spinning light clock shows time contraction. Time dilation, time contraction, and time conservation are all possible to happen. The second point is the connection between relativity and quantum mechanics. The behavior of time is linked to the quantized value of the angular velocity of the frequencies of the oscillating motions. Thank you.